right, everybody, today we're continuing with Chapter 9, Section 6, dealing with dilations. Now, it says right here, let's check this out, it says triangle CPQ. Wait, we're on problem number 4. CPQ, which is this little guy right there. Okay, he is a dilation of triangle CYZ. And triangle CYZ is the whole triangle, which is right here. I'll shade in the whole thing. Wow. Wow. So it's a dilation of, see, I got to color in the whole thing. So what's happening here? So besides my horrible coloring that my kindergarten teacher would cringe at. Other than that, what's happening? I'm going from big to small. So everybody, if you're going from big to small, what kind of dilation would that be called? What do y'all think? That's definitely a reduction. Okay, so a little review about what a reduction is. A reduction will have a scale factor, and that scale factor will always be less than the number 1, but it will be greater than 0. So our scale factor that we find for this problem, what's it have to be? It has to be a reduction, yes, but it has to be a fraction. Now a fraction is where the numerator is going to be smaller than the denominator, right? So it's not going to be an improper fraction, it's going to be just a regular fraction. So how in the world can I figure out what that is going to be? So here's a suggestion. If you would, please, get out your protractor with me, and we're going to look at a couple of right triangles. So check this out. I'm going to make a right triangle right here. I'm going to compare, I'm going to make that right triangle, and then I'm going to make another right triangle right in here. So pay very close attention to those two right triangles. So here's one right triangle right in here, and here's the other right triangle. So I'm going to shade this nice and neat so we can kind of look at these right triangles, because these right triangles that I just made are similar to each other, which means they all have the same angles, but one is slightly smaller than the other one. Now, I want you guys to carefully count the distance going up. How many squares does it take to go up right here in this right triangle? 9 is correct, so put a 9 right there. How many over does it go? 3. By the way, if you're wondering if we're recording, we are. So feel free to be quiet. So at this point, how far am I going up right here? 3. How much over? 1. So let's think about these two right triangles that you see before you. You see two right triangles. One right triangle looks like this. One right triangle looks like this. Here we have a 9 and a 3. Here we have a 3 and a 1. I want you guys to carefully compare these sides and these sides. If 3 goes to a 1 and 9 goes to a 3, that is definitely a reduction. It's a reduction by what scale factor? What would I have to multiply a 3 by to get it equal to a 1? 3 times what is a 1/3? That's right. So 9 times what number gets me to a 3? 9 times 1/3. So right here, what is our scale factor?
1/3.
1/3. So we have a reduction, and the reduction is equal to the scale factor of 1/3, because we went from big to small.
Right.
Okay? Because at the very beginning of the problem it says triangle CPQ is a dilation of this triangle, which means this tiny little guy is shrunken down by a scale factor of 1/3. And that's what your job was on. Okay? All right, moving on to the back page. What we're going to do is we're going to look at problem number 7, because it's an irregular looking shape. Let's take a look at it. In this irregular looking shape, we have the original image. You'll notice the original image is the smaller image. All right? And the new image is much larger. And what are we trying to find? We're trying to find what is the scale factor. So automatically we know, without having to do too much work, we know that this is definitely an enlargement. That's an enlargement. So we know we're going to be dealing with an improper fraction. A number that's what? Our x, by the way, x represents the scale factor that you're going to be looking for, right? X is going to have to be greater than the number 1. So whatever our scale factor is, it better be bigger than a 1. So what I'd like you to do is I would like you to put a point right here. And I want you to put a point right there. Right here at the tip. And right here at the tip. Okay. Now, what is the ordered pair for that right there? What's that ordered pair?
2, 2.
2 and a 2. And what is the ordered pair right up here? That's a 5 and a 5. So that's one thing we're going to look at. Okay, let's go over here. We're going to put a point right here and a point right there. Now, what is this ordered pair right there?
A negative 2, 0.
Good, negative 2, 0. And what's the ordered pair right here? Negative 5, 0. Good. All right. Now, this one's a little bit trickier. This will be the last one that I do. Put a point right here. Okay? And we're going to put a point right here. Okay? So this one's a little bit trickier. So I'm going to put it over here in green. We have negative 2, positive 3, right? Negative 2, positive 3. Now over here, how far does this one go all the way over? It goes negative 5, right? Negative 5 over. Now how much does it go up? 1, 2, 3, 4, 5, 6, 7. About 7 and a half. Now, I want you guys to look at the comparison of the x values and the y values. Let's put the blue over the blue. If I have 5 over 5, and I have a 2 over a 2, look at the relationship. If I just made those into a fraction, or if I made these into a fraction. What's 5 divided by 2 and 5 divided by 2? 2.5, right? Your scale factor, everybody, your scale factor is simply 5 over 2, which is equal to a 2.5. But I would like you to leave your answer as an improper fraction. Is that bigger than 1? Yes. All of these points were multiplied by 2.5. What's negative 5 divided by negative 2? Still a what? Positive 5 over 2. Do 7.5 divided by 3. Look what you get. If you're not sure, watch. Just do.
What did you say? 7.5 divided by 2?
No. 7.5 divided by 3. Look what it equals. 2.5. What does that prove to you? The scale factor, no matter what you did, the scale factor is still what? 5 over 2. You're like, wait a second, what about the red? Look at the red. Now, obviously, if we have a negative 5, 0, and we have a negative 2, 0, we can't do the 0 divided by 0, but what could we compare? The negative 5 divided by the negative 2. That still gets us what? 5 over 2. So all of these points, the red, the blue, and the green, they were all multiplied by 2.5. So the larger image is 2.5 times. All the distances are greater than the original. So your answer is, it's an enlargement, and it's what? 5 over 2. That's what you're doing. You're looking at things you can actually compare. So I don't care which problem you're working on. Okay? What are you going to be comparing? You're going to be working with scale factors throughout this entire assignment. Good luck.
Oh, yeah.